Okay, hello everybody. So this is my second time recording this video. I just talked for the better part of 40 minutes, and then I realized that it was not recording. So, but that's okay. Now I know exactly how I want to address this matter. Okay, so this video is going to go over how the exam is going to be delivered through the sapling format. So I know I've gotten a lot of questions about this, and I want to assure everybody that this is something that can be done. There are some things that I'm going to ask that you take your time and consider while you're doing these exams, okay? So they are open note and open book, and I have talked to the sapling representative. It will not lock down your browser, so if you do have your notes online or stored on your computer, you can go and view those while you're taking the test. Okay, so the first point that I want to talk about, and this is very important, is please read the entire question first. So whatever, don't make any assumptions. There is often wording in the question that tells you exactly what you need to do. And the other thing is that some of the questions have more than one part. So please don't be in a rush to get through the question, to get to the next question. Make for sure you look at all of the components to the question before you move on. Okay. The second thing is to try to work it out on paper before you answer, okay, the question. This may help if you're not really seeing what they're wanting to ask, and it'll help prevent you from making mistakes, silly mistakes like leaving a carbon out or putting an extra carbon in. So just take maybe a little bit of extra time and write it out before you submit your answer online. The other thing that is an issue is some of the questions do expect that you show hydrogens and lone electron pairs along with formal charges. The question will specify this though, okay? And you will often see it in the substrate itself, what it is that they're wanting you to show. So don't make any assumptions. If it says to show the hydrogens and the lone pairs, please do so, okay? The other thing I want to mention is that I believe this is a solvent I did talk about in class, but I want to make for sure it's mentioned here. DMSO, that stands for dimethyl sulfoxide. It is a polar aprotic solvent. It is an excellent solvent for doing SN2 reactions, and it is used quite frequently in that you'll see in some of the questions on the exam. The other thing to mention here as well is the test does expect you to draw functional groups out. So in other words, if you're used to just writing a nitrile as CN, you're going to want to write that as a carbon triple bond to nitrogen, and often shown the lone pair here as well. And this is just something you should get used to, okay, when you're drawing out the structures, okay? And again, just make for sure you have read the question when you're doing this. All right, so now I want to go ahead and turn to the share screen with everybody. And I'm going to go back to my main sapling page. We're going to walk through this whole process together. So this is going to be the same for both of my 2341 sections. You all are going to have the same style test, and the sample test that I put in there is going to be the same for both sections. So everybody's going to be seeing the same thing. Okay, and so what I have done is I have created a sample test. This is something everybody can view. This isn't for credit. This is something you just practice on so you get a kind of a flavor for the types of questions that you're going to see. Now, when the test goes live, the test will be available. You'll see it nested right after chapter 7. And so I have 2 links, and these will come active when the test goes live. Excuse me. So you'll see here that I have set the exam to start at midnight on April 7th and run all the way through 11:59 p.m. This is its availability. You will have 2 hours once you click on the link and you get started, okay? There's no way to stop the timer. And so once you have clicked in, you are committed to taking the test, okay? If you start the exam at 11 p.m., you are going to run out of time. So make for sure that you start the exam earlier than that, like 10 p.m. at the latest, so that you have the full 2 hours. If, however, you have accommodations, then you will see there is going to be a second link. Everybody's going to see both links. There's no way for me to just have some people see one and not the other. So everybody's going to have both. But if you have an accommodation, make for sure that you click on the accommodation link here, which will give you an extra hour to take the test. It will be available at the same time periods, though, okay, as well. All right. Now, for you guys, your test is going to be 30 questions. All the questions are weighted the same, okay? I have worked all of the questions. I have verified the solutions, and I do think that the questions are manageable, okay? So I've tried to eliminate anything that seemed confusing or out of place. I know there are a lot of questions in the homework that appear that way. They may be poorly written, and that just may be the nature of that particular homework question. I have tried to eliminate that in this test. I'm not saying that it is perfect. I'm not saying that there are no issues with it, but this is kind of the cards that we have been dealt. So this will work for us, okay? So let's go back to that sample test. Click on that. And what I'm going to do is I'm going to click on student preview. So this is like what you would see if you were taking the test. And this is not what I want to see. Go back and kill that. Okay, go back to this again. That was from what I just got done doing for the last hour as I talked to myself. Clear attempts and launch. Here we go. Okay, now, so this is what's going to happen is all the questions will be available. You will have one attempt to answer the question, and there is a place where you can do your check answer over here, okay? And so when you're looking at these questions, it's important that you read the question that's provided, and maybe jot some information down. So to save time, I've kind of already gone ahead and done this a little bit. So it says for the SN2 reaction, so it's telling you it's doing an SN2, draw the major product and select the correct RS designation around the stereocenter carbon in the organic substrate and organic product, and indicate wedged and dashed bonds and draw hydrogens on the stereocenter. So here it's clearly saying to draw the hydrogen atom. Okay, so for this one, I'm just going to go ahead and draw, just show you what the drawing feature does. So it immediately starts angling everything. So what I'm going to do is I'm just going to go ahead and I'm just going to pivot out and draw this like this, okay? And so this very last atom here was going to originally be my which was my chlorine here. If this is doing an SN2 reaction, it should displace that chloride from the back side. And so now in place of that is going to be your nitrile. So I told everybody that that should be a triple bond and there should be a nitrogen atom there, okay? Now, going back to that stereocenter, deuterium is an isotope of hydrogen, and so this is considered to be a different group. And so this is a stereocenter. So I'm going to go back and I'm going to put another bond here for my deuterium. Okay, and I'm going to put another bond in here as well for the hydrogen. These do not need to be exactly drawn the same way as this. What does matter is it says the stereochemistry needs to be correct. So if this came in and did inversion of configuration, well then that means the hydrogen and then this 3-carbon propyl group should have different configuration now. So I'm going to click on the wedge and I'm going to click on where the propyl group is, and you see I clicked it, it looks backwards, and click on it again, it puts it in the correct way. And then I'm going to do the same thing with hydrogen, except that is going to be dashed like that, okay? And so that's what the product looks like. Now, I know this is sticking out a little bit here on the end, but there's no way to help that. Notice they didn't draw any lone pairs around the chlorine, so that I can make that assumption here as well with the product. Now, coming down here, I need to talk about the stereochemistry of each. So I'm going to go ahead and do the stop share. I've already jotted this down, so we can kind of quickly go through this. And so I've indicated the stereocenter for each, the substrate and the product. Okay, and so obviously the chlorine is number 1, and then the carbon atom on the propyl group would be number 2. I'll wash it out there for a second. Okay, there we go. Deuterium is going to be number 3, and the hydrogen atom is going to be number 4. Okay, and so if we go 1 to 2, 2 to 3, 3 back to 1, that's rotating like this. It's clockwise, that's R. Check my number 4 group. Here it is wedged up. So that means it gives opposite configuration. So the substrate should have S configuration. Come down here, do the same thing. In this case, the nitrile is going to be number 1 because it's bonded to nitrogen versus this a propyl group, which is bonded to carbon, and nitrogen has a higher atomic number. So this will be 2, and deuterium has a higher atomic number than hydrogen. So 1 to 2, 3, 3 back to 1, still R. That's what we're thinking. Check the number 4 group. Number 4 group is now dashed away from us. So everything is A-OK. So the product should be R. Okay. So now I'm going to go back to the screen share. And so now I'm going to put that in. Okay, so the substrate is S and the product is R. So once you've done that, check everything that's in here. Go ahead and hit, it'll say submit. This is actually going to check the answer for you. There's an infinite number of tries on this sample test for you to get comfortable with it. But on the test, it's not going to tell you anything other than that you have submitted the question. And once you go through, and you can go back and change your mind, like if you want to go back and double check, that's okay. But there's going to be a button over here that you're going to see on the left that says submit, okay, and score. And it will warn you when you click it that that is it. When you hit that button again and you verify, it's going to turn your test in as if you had just turned it in for grading, okay? And it's not going to tell you whether or not you got the answers correct. The answer key should be available after midnight, okay, on so it should be starting April 8th if I have set everything up correctly, and then you can go in and check your scores. Okay, please do not, everybody do not email me if there appears to be an issue, okay? I cannot answer 100 emails all about the exams if there is something that appears awry. I will work on it. If you have an issue with me, please do not email me immediately after that. Give me at least a day or two to look at what has happened, and I will gauge at that point what I'm hearing from the class, you know, just in general, how everything went. Okay, so I'm hoping that this is going to go okay, but even I cannot foresee all the different problems that are going to arise from this. Okay, so just bear with me, okay, while we're trying this out for the first time. All right, now on question 2. Question 2, this says draw the major organic product for the reaction, indicate stereochemistry, include all hydrogen atoms at the stereocenter, and omit the byproducts of salts and methanol. Okay, so here we are told products. That's telling me there's going to be 2 things I need to draw. I look at this is a strong base. Methoxide is a strong base, and it is a good nucleophile. And here I have a secondary alkyl halide, okay? So this is the recipe for the possibility of E2 elimination, but it is also possible to have substitution here as well. I know this is a polar protic solvent, but methoxide specifically is a fairly small nucleophile. And so that means that substitution is a possibility. Okay, so I'm going to go back to the main screen, and we're going to consider that. So I've kind of drawn some notes here. So if methoxide were to displace the bromide, then that would do an SN2 reaction, and we should get inversion of configuration of that second stereocenter. And the first one should remain unchanged. Now, on this one, if this is going to do an E2 elimination, well, then it has to follow the anti-periplanar rule. So if the bromine is axial, okay, and see here it is being wedged, well, then that means this wedged group is going to need to be equatorial. So this hydrogen is axial, so it can eliminate. But there's also hydrogens over here to consider as well. So if this is going to be equatorial, then that means that hydrogen is axial also. The issue here, however, is E2 elimination prefers to give the Zate-Ceph product if sterics is not an issue. And this is not a sterically encumbered base. And so if we put the double bond here, it's going to be adjacent to this methyl group. Whereas at the double bond here, it will only be a secondary alkene. So with that in mind, I suspect that the major product is going to be this one, okay? And just to show you what the other one was that I was talking about versus this one. So this one is clearly more substituted. Okay, so these two products here are the ones that I'm thinking are going to be the major products that we're going to see in that reaction. Okay, so I'm going to go back to the screen and I'm going to try to draw those in. Okay, so for rings, those are conveniently done. You can just click on the ring. And so we're going to have a ring here. And notice how they drew the hydrogens in, and they said to include those. So I'm going to do that. So I'm going to put the hydrogen, there's going to be hydrogen here. There's going to be a methyl group here. Okay, again, it doesn't have to look exactly like that. It just has to have the same orientation. Hydrogen atom there. Excuse me. Okay, now the other group, which should have inversion of configuration, so that means the hydrogen group should now be wedged up. Should put a hydrogen there. And then now the other group is going to be dashed away from us. So there's going to be an oxygen there and a bond to the CH3. Now, notice that over here, they're using CH3 for this right here, and they're not showing the hydrogen. So I'm going to do the same thing here, and that should be okay. Now, for this one, if you draw this ring, then you can draw a methyl group here. And since this is now planar, do not need to show stereochemistry because those are no longer stereocenters. Okay, so that looks like the two major products that I'm going to have there. So I'm going to check my answer. Okay, and everything is looking good. Go on to the third question. Third question is we have it says draw the product formed from reaction of tert butoxide with this alkyl halide and draw the correct stereoisomer product. Okay, so again, singular product, I mean there's one thing I'm going to draw here. With this question, since this is a strong base and this is a very bad nucleophile, I suspect this is going to do elimination. And there are beta hydrogens on this carbon that can be eliminated. The problem is that the bromine is not anti to that hydrogen. And so that's something that I'm going to have to correct before I can do my elimination. So here I've redrawn this compound out here. And so what you want to do is you want to rotate this group so that the bromine, okay, is in fact now going to be pointing in the same plane. So here it's coming out of the page towards us. So we want to rotate it so that it's in the plane of where the hydrogen atom is. So what that is going to look like is now you're going to have the bromine here. Notice they're in opposite sides and they both have the same orientation. But what that does is it ends up now, when you rotate it like that, that's going to rotate the benzene ring, the phenyl group, so that it is now dashed back. And that hydrogen atom is now going to be wedged up. So when the butoxide does its elimination, you would expect to get something that looks like this, where the methyl group and the phenyl group are on the same side of the double bond, okay? So that's going to be the orientation that I'm going to want to draw out on our product. Okay, so doing that, we are going to start drawing in some bonds. So we'll draw one here, draw another one in. Okay, then I'm going to put a double bond here. Okay, so there's my ethyl group. So I want a hydrogen atom to be on the same side as that. So I'm going to put a hydrogen atom here. But then on this side, I want to have a methyl group. Okay, and then right here, this should be the benzene ring. And so if we go up to rings, there's benzene ring, put that there, and there it is. Okay, and so since they didn't draw in any of the hydrogens here, I'm not going to draw them in either. I just drew the one in on the double bond. Okay, so I think that's everything. So check my answer. Okay, so we got that. We're moving on. Okay, so now some of the questions are not going to take you a lot of time. Some are going to be like this, where you have some choices and you're supposed to put that in and fill the chart out. So here, this is a solvolysis reaction. It's asking you to rank the relative rates of solvolysis of the substrates in methanol in decreasing order, fastest to slowest. Okay, solvolysis is an SN1 reaction. Everything depends on the rate of formation of carbocation. And so if you have these three compounds, these are the three leaving groups that would have to leave. And so the best one with the best leaving group there is going to be the one with the chlorine. Chlorine can produce chloride, it's the best leaving group. Second best one be something like acetate. Okay, oxygen. This is not as good a leaving group as a chloride is. Again, chloride is a conjugate base of strong acid. Acetate is conjugate base of a weak acid. And then the one that should be the slowest is the hydroxide group would be the slowest one to leave. Okay, so check our answer. Okay, so see, that's the kind of question you can do in under a minute, and there will be some of those like that, so that will save you some time. Okay, now this question, I picked this one because this one is showing all the hydrogens, and sometimes you do see questions like this where they want you to pencil in all the hydrogen atoms and they say draw the substitution product. Okay, so for this question, what you are, I drew this out here. So what you're thinking here is that, well, water is bad nucleophile, it's a bad base. So if the bromine leaves, well, then that's going to give me a carbocation. And that carbocation will be tertiary. So that's look like this. So water can add into that positive charge. And when it does so, you end up with the two CH3 groups. Water has added in. And you have your two carbon group on the side. And just drawing it out like we did in class, you would expect elimination of HBr from this. Now, normally, we wouldn't draw all these hydrogens in, but I am because that's how the question had it. And so that's how I'm going to put this in as a product. So if we go back to the screen, and I click now on drawing in a bond, one of the things you'll see is that it already puts the hydrogen atoms in formula. So I've got another carbon atom here, so I'm going to click on it again. It's going to give me this. And then click on this again, and now I have my CH2 group. Go back to the carbon here, click again. Now I have my CH3. And then now I'm going to click on this a fourth time, and that's going to put in another CH3 group, which if I click on the oxygen, I can go over and change to an OH group. This is not a stereo center, and so this should be acceptable. Make sure I didn't miss anything in here. Nope. Okay, so now we're going to check my answer. All right. And so now we're moving on to the last question. Last question is consider the following pair of reactions, draw the neutral organic products, then predict the type of mechanism, and then compare the expected rates. Okay, so here we've got two reactions, both of which are solvolysis reactions. Water is going to be the nucleophile, and that means if it's going to be doing substitution, well, then that means both of these are going to have to be SN1 because SN2, you need a good nucleophile, okay? So now the products here, we're going to draw those in a minute, but looking down here, there's some additional questions, so don't miss these. So identify the mechanism of each reaction. So what we just concluded is that both of them are going to follow SN1 chemistry, but looking at this, it says, well, which one would occur faster? Will they occur the same rate, or is one faster, or is two faster? Okay, well, if we were to look at this a little bit more closely, the only real difference here is the leaving group. And if bromine is the leaving group, well, compared to that of, say, chlorine, I would expect that to be faster because bromide is a better leaving group than the chloride is, okay? So I expect that to be faster than with the chloride. And so if water goes and adds it to here, you end up with this species, and then following elimination of HBr, you're going to have this alcohol. And down here should be something very similar. Except you have elimination of HCl. But both of them are the same product, okay? But I would conclude that the first reaction is faster because the bromide is a better leaving group. Okay, so go back to that screen. And so I'm going to come down here. I'm going to go ahead and answer that question right now. So I think reaction 1 is faster than reaction 2. Then I'm going to go up here and I'm going to draw my products now. Okay, and it's showing that hydrogen, so I'm going to go ahead and do that as well. So it's got, we've got a group here, another one, and another one. Okay, and so I'm going to have a OH on one side and hydrogen on the other side, and that should be the same thing over here as well. So sometimes it moves it around. Just scroll up and down to find it. So hydrogen here, OH here. Okay, and I think we've answered everything. All righty, check my answer. Okay, and that is it. All right, so that is pretty much all I wanted to show you here. So I'm going to stop the share, go back to the video. Okay, so, and I will turn this around. Okay, so here I am. So guys, I apologize for the length of this video, but I think this is what everybody was wanting, was a little bit more in-depth explanation as to what you can expect on the exam on Tuesday. So I will be probably posting some more videos about Chapter 8 as well, which you can look at, you know, after we get through the exam on Tuesday. For right now, you should be focusing on studying and going over your notes for that. So I will be checking my email this weekend as well. If you have any additional questions or concerns, please get back in touch with me. And anyway, guys, everyone, I hope you all are doing well. Take care, and I'll see you again soon. Okay, bye-bye.